So this section is about how reflecting telescopes work. The best way I can show you this is by a picture. So what happens is a distant star, light from a distant star, comes down and into the reflecting telescope. Now the light rays are parallel to each other, so you'll have one here and another parallel light ray here. But just to keep it simple, I've only drawn one ray. And this light ray will reflect off the curved primary mirror. So it's going to reflect off the curved primary mirror, and then it's going to reflect off the secondary plane mirror. So a plane mirror is a mirror that's absolutely flat, straight and smooth. And then it will go through the eyepiece, and the job of the eyepiece is to magnify the image to make it bigger. Okay, and so that's what I've explained here. So parallel light rays enter the telescope, they reflect off the primary curved mirror, then they reflect off the secondary, made a mistake here, they reflect off the secondary, not curved, plane mirror, because it is flat and smooth, and then it goes through the eyepiece, which magnifies the image. Okay, and that's the next question is state what the eyepiece does, and it magnifies the image. So that's that done. Okay, pause the video, try answering the next question. Okay, so like I've told you guys already about these 6 mark questions, you need to see how best to divide the page. So reading the question, I've got for geocentric and against geocentric. Now the arguments for geocentric, what I've written is that the stars appear to move around us. There's sunset and sunrise, which makes the sun appear to move around us, and the moon appears to be following the earth. Well, it is, but and finally we've got, if you look at the earth, if you look outside your window right now, it doesn't look like the earth is moving. So those are kind of evidences and reasons why people thought it was a geocentric model before. Also, you could argue that some people from some religious communities stated that because God created us, this must be special creation, so we must be at the center of the universe. So that's like a 5th point you can put in. The next section I have is against, and so basically you've got the advancement of technology and telescopes, you've got Galileo's observation of the moons of Jupiter, and you've got space exploration where you can see, you can send up a satellite up into space and see how things orbit around each other and make a model of this, that and the other. Now obviously guys, I've written bullet points. You guys will have to write full sentences to gain the 6 marks. Okay, so pause the video again and try the next question. Okay, so this question, it's about P waves. P waves and S waves obviously belong to seismic waves and are earthquake topics. Now I just want to go through the way to remember what the properties of P waves are, and of course I use this bad boy here, and we're going to see that P waves are like piss, but they're not actually piss. So what we need to do is, because they are like piss, we need to turn the I into an L. So P waves are primary waves, they are longitudinal, so that means they travel in the direction of motion. The P waves can travel through liquids and solids, and just as when you need a real life, it ends up coming out very, very quickly, so they are really, really fast, and I've just called that speedy. So P waves are faster than S waves. Now, because we've talked about, we can now talk about, yes, that's right. So S waves are secondary waves. They can only go through solids. When you're constipated and you're having it's very, very slow. And they are transverse waves, so that means they travel at 90 degrees to the direction of motion. So if you look at this, what type, so this question is about P waves, so straight away you can cross out these two because P waves are not transverse. And so the question is, can they be refracted? The answer is yes. Every single type of wave can be refracted. Doesn't matter what the wave is, it can be refracted. It can be bent due to the different densities. So that answer is A. Next question is, why is it difficult to predict earthquakes? Well, number one, you can't see the tectonic plates, so you can't see the movement of the tectonic plates. Number two, it's difficult to predict exactly when they will move. And number three, you can't see the convection currents occurring in the mantle, so again, it's difficult to see. Okay, so pause the video, have a go at the next question, and I'll see you there. Okay, so with this question, it's saying to note the times for the P wave and the S wave when it's 4,800 kilometers. Firstly, you have to figure out what the scale is here, and this is basically, so I'm gonna go 4.268, 2, 4, 6, 8, 10. So each line is going up by 0.2. So if I go 2, 4, and what does it want? The question wants 4,800 kilometers. So it's going to be 2, 4, 6, 8. Then you're going to mark off P and S. So that's, I should have really used a cross because that would have been better instead of these silly lines. And then you're going to read off the time at each point. So for the P wave, which is down here, this was 8 minutes, and for the S wave, which is up here, it came as 14.5 or 14.5 minutes, because each one of these is 30 seconds, so each one of these is half a minute basically. So 10, just to show you, 11, 12, 13, 14, 14.5, 15 minutes. Yeah, so it's 14.5. So your P is equal to 8 minutes, your S is equal to 14.5. Your time difference, you just take them away and it'll leave you at 6.5. Pause the video, have a go at the next question. Okay, so this is one of the questions that I'm worried about if it comes up. Okay, so you need to really understand this. If you have any questions by the end of it, you can always ask me. Okay, so instead of using the seismic stations up here, I've decided to draw my own because it's easier to explain if I draw my own as opposed to these other ones up here. So what we've got is we've got 3 seismic stations, A, B, and C. So what they do is they basically allow for the location of the epicenter. Now the epicenter is the exact point at which an earthquake occurs. Okay, so you need to know that, make a note of that. The epicenter is the exact location where the earthquake occurs. Now, as you can see, station A and station B, which are over here, they have recorded a disturbance by an earthquake along this path here from station B. I've labeled it B. So this path here, somewhere along here, there's an earthquake. And station A, somewhere along here, there's been an earthquake. But there's a problem now. Can you see, with only 2 stations, we've got these 2 intersections. So in other words, what it's saying is that the earthquake could have happened here, or it could have happened here. So that leaves us confused. Where did it happen? Did it happen here or did it happen here? We don't know, which is why you need a 3rd station located nearby. And so I'm gonna show you I'm gonna draw on the 3rd station reading, and then I'll start recording again. So just bear with me. Right, so seismic station C has recorded that somewhere along this line there's been a disturbance. But if you look at A, B, and C, they all meet at this point. Right, and this is called triangulation. So this is called triangulation. And basically triangulation is when all 3 points, all 3 seismographs overlap each other. And so you've got 1, 2, 3, they're all overlapping each other. So this is where the earthquake happened. And as you can see, before when we only had 2, we weren't sure. And this is why you should have 3. So I hope that makes sense. So basically, seismometer A, seismic station A, seismic station B, and C, they all draw seismographs which lay out where it could have possibly happened. The best way to do this is by triangulation, where all the points meet. This is called the epicenter. So this part here is called the epicenter, and this is where the earthquake actually occurred, where all 3 points meet. So, and that is basically your 6-mark answer, basically. Yeah, and obviously it's best that we collect. If you only had one seismic station, that would be rubbish because you wouldn't know anywhere where it actually occurred. 2 is a bit better, but you still got points of confusion. 3, you got triangulation, pinpoint very, very closely the epicenter. Okay, so I hope that helps, and that is the end of this exam paper, which is May 2015. And guys, like I said, the same questions keep coming up every single time. Very easy exam. This is where you make all your marks.